All right, morning, boys and girls. It is, well, it's Tuesday, but we are working on math lesson 2, problem set of module 6. So we're working with decimals. Now, I realize I don't have a ruler. Yeah, so I still have to get my packet of work that you have, or that you may have and may not have. It depends on if your parent was able to go pick up your packet yesterday. Any old ruler will do, though, as long as it has centimeters on it. There is, if you got the packet, there is a paper ruler in there that you can cut out. I just don't happen to have that on me right now, and I don't have a ruler near me currently, but that's okay. We can do this without. So the concept, well, the objective today is use metric measurement in area models to represent tenths as fractions greater than 1 and decimal numbers. What we're doing today, that may sound a little complicated, but it's super. Oh, hi, Penny. Penny, can you lay down? Probably should just start this all over again, shouldn't I? Anyway, you'll totally understand it, and you'll be like, yeah, this is good stuff. So let's think about what we did yesterday. Yesterday we talked about 1/10, and representing that as a decimal is 0.1. So that's 1/10. 2/10 would be 0.2, but you would read it as 0 and 1/10, or just 1/10. This is 1/10. This is 2/10. You can read it as 2/10. So you could say 0 and 2/10. Either way, it's 2/10. 3/10, 4/10, 5/10, 6/10, and so on. And we also showed a tape diagram, right? Cut into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, and each one representing 1/10, right? And we can do our number line, and we can write it in fraction form, and we can write it in decimal form. 0.1, 0.2, 0.3, 0.4. Now I'm not exactly saying it correctly. I should be saying 0 and 7/10, or I could just be saying 8/10. But when I go quickly, that's what I end up doing. All right, so, and these would all be 1/10, right? And then this together is 2/10, and 2/10 is 0.2. And we also looked at ways to make like 1 centimeter, 1 whole. So if we have 2/10, how many more until we get to 1 whole? That would be 8/10. All right, so that was yesterday's. Today is not really similar, actually, but it is kind of, well, it's certainly related, isn't it, seeing how we're doing decimals, but it is a little bit different. So today you're supposed to look at a ruler. So we're going to pretend that I have a ruler. And on my ruler, I'm looking at the centimeter side, okay? So 1 centimeter is actually pretty small, right? Centimeters are actually really small. Their inches are bigger than that. If you look at your ruler, you might have a 0 here. You might not. Remember, that's where we just line up with that first big line. Sometimes it's the edge. Sometimes there's an actual line. You'll have a line that is a little bit longer there. And then you'll have 4 other lines. And I know you can't see what I'm doing here. That's okay. 1 centimeter can be broken into tenths. So 1 centimeter can be broken into basically 1/10 plus 1/10 plus 1/10. Imagine our tape diagram, imagine our number line. 1 centimeter is broken into tenths. So when we measure things, we measure them usually to the nearest tenth in centimeters, because that's very small. In inches, it's a little bit different. We could do like 1/4 inches and 1/8 inches and so on. But for centimeters, we don't usually measure to the nearest centimeter, it's usually the nearest tenth. So that ladybug yesterday that we measured, even though it kind of had the ruler on there already, it was 5/10. You wouldn't say that that's 1 centimeter. I mean, if you had to, if they asked you to do it to the nearest centimeter, then obviously the ladybug would have been 1 centimeter, but usually it's to the nearest tenth. Okay, so but those lines are broken up just like your regular number line, so you can just count. So today we have a whole number, or we have a whole number. So basically we're going to have more than one for centimeters, and we want to figure out how to represent that. Now there's a few different ways. Our mixed numbers, boys and girls, they have more than one, right? So our mixed number, like if we have 3 4/10, that's a mixed number, okay? But we want to write this in decimal form. I bet you already know how to do it, but I'm going to show you anyway. So this is 3 wholes, right? And this is 4/10. I didn't do anything. I just kind of separated them just so I could see that a little bit better. How do we write 4/10 with the decimal? Well, we know that we write 0.4. So really we're just doing 3 plus 0.4. Why am I saying plus? Well, I want to put them back together. So 3 wholes plus 0 wholes really is 3.4. Now, if I were going to add this, like some of you are like, oh, okay, let's just do it like that. Well, no way is that right. Not that we're even at this point where we're going to add decimals, but there's no way that you are going to line it up like that. So be very careful. Remember what I showed you yesterday is we have our hundreds, our tens, our ones, and then we have our decimal, right? And then we have our tenths, and I'm going to write tenths. It's not tens, it's tenths. So if we have the whole number 3 and we have 4/10, oh, look at that, it's 3.4. So this is, you know how I always pre-teach you stuff? This will come up later, but I just wanted to point that out, so just be careful with that. So 3 4/10 of the fraction that looks like this, you write it like this. And what does it represent? Well, let's take a look at it. If we were using a ruler, which I'm supposed to be, say that's 1 centimeter. And that's 2 centimeter. And these are huge compared to what they normally are. Remember, centimeters are pretty small. So this is definitely not drawn to scale. 4 centimeters. So in between each of these would be 9 lines. Here's our 0. 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent the 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's as far as I'm going to go. Now again, I'll get a little closer. I should have a ruler right now, but I just don't. So my 3 4/10, which can be written as 3.4, that says 3 and, remember how I always said when you see the number like 326, do not put an and there because and means decimal? There we go. This, we say and, 3 4/10. So where's 3? There's 1, 2, here's our 3, and now we have to go 4/10. 1, 2, 3, 4. So if I were to draw, like if I were using my ruler to draw 3 4/10, I'm going to start at the 0, and I'm obviously going to use my ruler and use it correctly. And I'm going to draw all the way to 3, and then I count 1, 2, 3, 4, 4/10. So that actually brings us to the beginning of the problem set. So there's one other thing I'm going to teach you with the problem set, but I'm going to start with the first section, and then I'll teach you the next part. So the first section, boys and girls, is all you actually have to do is this: for each length given below, draw a line segment to match. Express each measurement as an equivalent mixed number. Super, you're like, wait, what am I supposed to do? You got this. So we have 2.6. 2.6 is, you could say it is 2 6/10, right? Write that as a fraction. Oh, that's an easy thing. 2 6/10, right? You can say 2.6, 2 6/10. I think those are the only ways to say it. I don't know if you could come up with another way, but so write it as a fraction. And now all you have to do, boys and girls, is take your ruler and draw a line, well, a line segment, because a line continues. Remember, our lines have the arrowheads, but we're just drawing a line segment, which means we're just drawing like that. But you're going to take your ruler, start at your 0. You get it? Get it ready? Because I don't. And then you'll see that's 1 centimeter. Why do I keep putting the C there? That's 2 centimeters. And then, are you going all the way to 3? No. Go, you'll probably see 1, 2, oh, so this is my 3. So you'll probably see a little bit of a longer line there to show you that that's halfway. That's 5/10, so you go to that one. So you just, all you have to do is measure 2 6/10. Clearly that is not 2 6/10 centimeters. So you're just going to draw a line. If you want, you could take a picture of the work that you did if you were able to do it. See, you can even just do this on a piece of paper. Take a picture of that point and send it to me. Although I can't really measure it because it's a picture, but well, whatever, right? Next one is 3.4 centimeters. So 3.4 centimeters means it's 3 4/10. Okay, so now take your ruler and draw a line segment that is 3 4/10. So you're going to start at your 0 or the edge of the ruler, and you go 3 holes for centimeters, and then count the 4 little ones and 4/10. And that's all you have to do for that. And then C is 3.7. So this is read as 3 7/10. So let's write it as a fraction, 3 7/10. And then go ahead and draw 3 7/10. So you're drawing one line segment, one continuous line segment that goes almost to 4. You're pretty close to 4 centimeters, but not quite. We would need 3/10 more to get to 4 centimeters. Okay, D is 4.2 centimeters. So this is 4.2 is 4 2/10. So our fraction is 4 2/10. Penny's sleeping, she's snoring. And draw your line segment that is 4 2/10. So go to the 4, and then you have 2 little marks after that. And the last one in this part is 2.5 centimeters, which is 2 5/10. So let's write 2 5/10. I just realized I forgot to write centimeters for our fraction for the other ones, I think, but you should definitely do that. So now you're going to go ahead and draw a line segment that is 2 5/10 centimeters. So you go to the 2 and then count 5 little lines. It probably has a longer line in the middle, and that's your 5/10. All right, so the next part is the second part of what I'm teaching you today, like the second part of the lesson. So we have all of these boxes. We have all of, well, not boxes, but instead of doing a tape diagram going across like that, we have, I'll turn it sideways. Okay, so they have, I'm going to do 3 of these right now, okay? I know you have 5 on yours, but I'm just going to do 3 right now. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is terrible, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, That was really bad, but that's okay. All right, so it says write the following as equivalent decimals. 2 ones and 6 tenths. So this is what it says in our problem set. Is the ones part throwing you? Hopefully not. 2 ones, if we look at a place value chart, we have tens, ones, our decimal, and then tenths. I'm going to put TH so we remember that, right? Well, I don't have any ones, or tens, excuse me. I have 2 ones and 6 tenths. Oh, so it's 2.6. So there's our decimal, 2 and 6 tenths. This is in our ones. See, it wasn't as bad as you thought. Now you look at this and you're like, wait a minute, what? Well, this is representing what? I mean, it has tenths. Well, how many tenths does it have? It has 10 tenths, right? 10 tenths is the same as 1 whole. This is representing 1. So if we shade in all of this, that's 1, but we need 2. So then we shade in all of this, and that's 2. So go ahead and shade in 2 of them. We just shaded in 2. That's all we did. Makes more sense now, doesn't it? Now we have to do 6 tenths. So how many lines, how many of these am I going to color in? I'm going to color in 6. 1, 2, 3, 4, 5, 6. That shows two wholes and 6 tenths. And now you're like, oh, and then if we look at the bottom, I'll show you the bottom. If you don't have it, it shows you 2 and 6 tenths as a fraction is 2 plus 6 tenths. Well, we had the 2 wholes and then you colored in 6 of these. 6 tenths is written as 0.6 to 0.6. So now we flip it over to the back and look, we've got 4 problems where we need to change this into, we're writing it in decimal form, correct? Yes, we write it in decimal form and then we just shade in the right amount. We got this. Okay, so we have 4 ones and 2 tenths. So don't let that get you confused, okay? I know it says 4 ones, but 4 ones, if we are doing a place value chart, here's my decimal, this is my tenths, this is my ones, right? I know I'm not really supposed to show you the place value chart right now, but I think it's silly not to. So it says we have 4 ones, and then we put our decimal, right? And then 2 tenths. Well, look, there's our decimal right there, isn't it? Or, well, there's our number written in decimal form. 4 and 2 tenths. Okay, so what do we do for, ooh, there's a little typo in mine. So we have 1, 2, I'm going to erase this, boys and girls. I got to scooch this over too. I need 5 of these. 1, 2, 3, 4, 5. Those are supposed to be the same, all the same. So sorry that they're not. I'm also going to take a little shortcut and not draw all the lines for all of them. They're already drawn on the problem set, so you can just color it in. Now I have to do 4 ones. 4 ones means 4 wholes, right? So each one is 10 tenths, which is 1 whole. So how many of these do I color in? I color in 4. 1, 2, 3, 4. Now this last one, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not bad. Now we have to do 2 tenths from there. So I've colored in 4 holes and now I color in 2 tenths. And that's it. This is 4 and 2 tenths. This is 4 ones because each of these is worth 1 whole and 2 tenths. Okay. C, we have 3 and 4/10. 1, 2, 3, 4. I don't need to draw a 5th one. You know why? Because I know that 3 and 4/10 means that I'm going to have 4 of these. Because I have to color in how many holes? 3 holes, and then 4/10 of this one. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 3 and 4/10, right? 3 1s and 4/10. But you already knew that. So we color in 3 hole, 1, 2, 3, and then we color in 4 of these. 1, 2, 3, 4. 3 and 4/10. Beautiful. D is 2 and 5/10. So I'm going to color in 2 holes and then 5/10 of the other. What's my fraction? Or no, my fraction is 2. My fraction is 2 and 5/10. So my decimal is 2 and 5/10, 2.5. Okay, so I color in, or I need how many of these? Well, there's my 2 hole, right? 1, I color in this, 2, and I need another, and I need to break this into tenths. 1, oh, that's terrible. 2, 3, 4, 5, 8, 9. Okay, so I color in 5 of these, right? 5/10. 1, 2, 3, 4, 5. So, ooh, they have a little bonus question. How much more is needed to get to 5? To 5 whole? Oh. Okay, these are not drawn to scale. These should all be the same. They're not. I apologize. It just kind of is what it is right now. So, these should be broken up too. But how much more is needed to get to 5? Okay, so we are at 2 and 5/10. I bet you some of you figured it out. I can see it in your face. Wait, I can't see your face, but whatever. How many holes do we still need to color in? So that's 2 1s, and how many tenths? 5/10. So you can write it like this. How much more is needed to get to 5? 2 and 5/10, or 2.5. Now I bet you a lot of you knew that because you knew that 2.5, 2 and 5/10 was half of 5. Excellent. Ooh, look at this next one. It has 37/10. Oh, how dare they have an improper fraction? Well, make it a mixed number. 10 goes into 37 3 times. You can do it on the side. And I have 7/10 left, right? Whoops. So 3 and 7/10. Okay, so I have to erase that so I can draw my boxes. So the number we're starting with is 3 and 7/10. 2, 3, 4, 5. Okay, so we have to do 3 and 7/10, which we can write as 3.7. So we color in 3 whole, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not bad. That's my best one. 7/10. So let's color in 7/10. 1, 2, 3, 4, 5, 6, 7. I feel like I'm going cross-eyed with this right now. All right, so we did that, and now it says how much more is needed to get to 5. Well, we need that 1 whole, and then how many tenths are left? 3/10 are left. So we need 1.3 more to get to 5. And look at that. There's lesson 2 problem set. It wasn't that bad, was it? You got it. Good job, guys.